Everyone, welcome back to the shop. Today I'm going to be answering a question that you guys ask me all the time, and that is, what welding table should you buy? There's no such thing as the perfect welding table. Everybody's needs are a little bit different, so that's why I've gathered 10 welding tables here today, and we're going to pick them apart and hopefully find out which one could be best for you. We're going to be looking at the size, the shape, the weight, ergonomics, accessories, and testing some of them, and of course the build quality and construction. Table manufacturers would never show you how flimsy or stiff the tables really are, so we're going to purposefully put the table into flex to see how much deflection the table has. In the welding world, having a perfect surface is pretty rare. We're going to see how close these table manufacturers can get to perfection. So we're going to identify what the surface of these tables look like. But of course, it could look like a bowl. It could look like a dome, a potato chip, a mountain, skateboard ramp. It could literally be any shape. I'm going to be doing this with this precision 14-foot straight edge that I call the Heartbreaker. It's going to allow me to find all the surface imperfections on all the tables. Aerospace fabrication is the most demanding on these fixture table manufacturers, and their requirements state that they must have a welding table that's plus or minus 2.5 thousandths of an inch over 24 inches. So I will be using this as the standard, and we'll see what tables meet this requirement, and I will give it a pass or fail based on these parameters. What are we waiting for? Let's take a look at the tables. The first table we're going to dissect today is the Weldsale table, and it's one of the original fixture table designs. At $9,090, gets you the platen and the legs that it sits on. This table is a one-piece gray cast iron platen. It measures about 6 inches from the bottom of the platen to the top of the surface, and this is a 5x8 table. The table weighs 3,775 pounds. The table surface has been machined flat, and because it's cast iron, it is going to be highly weld spatter resistant. It's sitting on a mild steel stand that has 6 legs constructed out of a 2x6 inch mild steel tubing. You can buy the platen separate from the base, but in this configuration, we have both, and it sets the height at 32 inches. It's just held in with these 4 bolts in the corners, pretty simple. So you can put them adjacent right next to each other and make a huge long table or a whole bunch of tables together. And there's ribbing that runs in a cross section form underneath. And it has 1 3/4 inch holes that have been cast into the surface of this plate. The holes are also designed for fume extraction. They're as cast, so you got to be careful when you're using them for precision locating. And every table is going to be a little bit different, so keep that in mind when you're using the holes. I like the table height because I can reach across it with ease, but when I pull my chair up to the edge of the table, I find that my knees do hit the edge of the frame, but there is no cross members, which allows me to store things underneath it, put my TIG pedal on the edge of the table, and also sweep with ease. I think we're ready to do some tests. 3 corners are supported. The 4th corner is jacked up to get it really out of level. All I was able to do is get 100 thousandths shim in the center of this table. Now we're going to level it out to test its maximum flatness. The table doesn't come with leveling feet. We're going to have to either shim it or come up with another creative solution. I couldn't get a 5,000 shim anywhere underneath this straight edge, no matter where I placed it on this cast iron platen. So definitely passes the aerospace test. Let's talk a little bit about the fixtures that you're able to purchase when you buy a table like this. They offer these fixtures in thick, heavy cast iron. So they offer these pegs to be able to put your material right on top of that, and then plasma cut these bending posts to use the frame of this table to do some bending. These 3-sided surface blocks that you can be able to put a clamp into or be able to bolt it right down to the table. They got everything from small, medium to even just a quick little single bar slide. The table has a cool pattern cast into the bottom, which allows the locking nut to the fixture to be held in place. All you have to do is turn the nut 45 degrees and the table locks the nut into place. Pretty clever. I think this is unique to Weldsale. Before the sliding bar clamp came the gooseneck clamp. It's still relevant today because of its simplicity, and it's cheaper. And these are basically a piece of spring that you can now hammer on and put a part underneath here and be able to do some hold down clamping. You do have 12 inches of reach. I'd like to be able to do a clamping force test with these gooseneck dogs compared to something like the Bessie clamp that they also offer in all different heights. These are bigger than any other table. So I'm just gonna smack it a couple times on top of this meter and just see what kind of force we can get. That was 643 pounds with a couple light whacks with the sledgehammer. Now let's test a Bessie clamp. That's 2,000 pounds of force. I'm not afraid to destroy the table by putting excess force when clamping. So what I like about the table is that it's heavy duty. Put anything on it and know that it's not going to sag, bend, or twist. And that's all due because it is cast iron. Cast iron doesn't like to bend. It doesn't like to twist. It doesn't like to move. Also, the fixtures are cast iron, so therefore you get the same benefits in all the accessories that you do and you stack on top of the table. The clamps that come with this table are the largest clamps that I've seen on any fixture table. This welding table I measured is flat, so therefore if I wanted to build anything on it, I have an excellent foundation to not limit me on what I want to build on top of it. I wish this table had holes on all four sides. That way I'm able to put clamps or extend the fixture surface out the side. I want to say thank you, Weldsale, for sending us a table here to review today. There's a lot of little bits and pieces of information I didn't cover, but is on the Weldsale website. I'll link in the description below. Let's take a look at the Siegmund 28mm table and examine all its cool features. This table sets you back $8,500 and the legs come with it. The table measures 2,400 millimeters long and 1,200 millimeters wide. But for you guys that live here in America, it is 94.5 by 47.25, which it's undersized of a 4x8 table. I wish they would have made it an extra 100 millimeters wide in every dimension to accommodate for the 4x8 sheets that we generally use here. The 28mm hole is on a 100mm grid pattern. Siegmund's provided this really nice linear scale that runs around the perimeter of the whole table in 100mm increments. The table measures approximately 37.25 inches, which makes it easy to pull up a chair, see how it feels. Oh man, table's pretty nice to sit at without the cross members. It's kind of tall, but easy to run a broom under or store something underneath. So I'm going to put the table into twist and measure it for flatness. This is going to simulate the table being on wheels, and the wheels would be following the rough concrete. And then let's see how flat it would maintain in that condition. So we have easily 65, 70 thousandths of droop on the corners. So now it's time to level it and we'll see how flat we can actually really get this table. Whew, okay, this is by far the longest table to get level. So the table is high in the center, and no matter which way I measure it, I can't get that center to come down by moving the four legs. Because in the aerospace test, we're only dealing with a 2x2, yes, definitely flat enough for that. But overall, in the 9.5 feet from corner to corner, I'm getting 5 thousandths. How accurate are these holes spaced? So let's measure and find out. All the holes are on a perfect grid, and you can rely on them. How square is the surface to the sides? Well, I was not able to get a 3/1000 shim anywhere as I walked the square around the perimeter. So that's pretty amazing. 2/1000 sag out there at the end. Pretty good. Passes the sag test. Looks like 780 kilos is 1,587 pounds. Let's take a closer look at some of the fixtures for this table. Siegmund's provided some very large four-sided fixtures that are made out of cast iron, and they're absolutely beautifully machined. They all have the same chamfer, a really nice radius on all the edges or wherever a hole is. There is no provision to set it at a custom angle if you position the square flat on its side. Siegmund's also provided the scale that matches the table on the edge of every fixture. That way you're able to match the scale on the table with the scale on the fixture. There's options for small angle plates, tall angle plates, large flat plates, and even these 120-degree V-blocks that you can place on the fixture themselves. The ball lock bolts feel really heavy in the hand, and they have this really nice knurled knob. But if you can't get a good enough grip on them, there's a provision for an Allen key. All the fixtures are also nitride coated to help aid in weld spatter and preventing rust. The clamps have this really cool sliding bar design. We're able to adjust the height and then lock it into place. These clamps are pretty cool, and I want to know how powerful they are, so let's test them. Let's test the clamping force with the minimum reach setting. 1,653 pounds. And I noticed with the lot finer thread pitch, it goes pretty high. Now let's move it out to the maximum, 1,366 pounds. These clamps have a way to use an Allen wrench, 1,719 pounds. Let's test the clamping force with the minimum reach, 2,204 pounds. Clamp's pretty cool. It's got this knurled back on the bar, which helps it grip. Got 2 axes of sliding motion and then 1 to lock it into place. Then you can pull the foot off the bottom, which got a really nice deep V groove, and put this inside one of the holes. So there's a threaded insert inside this. That's the nut to the clamp. Now you can put it anywhere. You can put it into the side of the table, into one of the fixtures, and then use this spindle to push. As you notice, a lot of these clamps and fixtures have O-rings on them, and that's to prevent like twisting and turning and keep the slop out of it. Seigmund has provided this really nice radius on the edge of the hole. The table has 28mm holes, which is going to be extremely handy because the ball lock bolt diameter is now bigger, which increases the strength of the bolt. And I'm not going to be too concerned about bending the fixture when it's bolted to the table. I like that the table's heavy duty so that I could place large weldments on top of it. I love having these 4 sides around the perimeter of the table. It's going to help with bolting fixtures to the side to extend the working surface, or marry 2 tables together to make one huge giant table. I found it was really difficult, and it took me the longest to get the table level because of its lack of rigidity. I would have liked to seen more cross braces underneath of it. The table only has 4 legs, and I did notice that bolting the legs on was kind of a pain in the butt. I had to have a special tool to get down there and fasten the legs on it, which is no big deal. You're only going to do it once. The one thing that gives this table this beautiful color is this nitrate coating they put on it. Because this table is steel, the nitrate also helps keep the table rust free. It's coated on the top and bottom of the table, isn't it? Oh yeah, it is. Generally, I think the tabletop will last a lot longer because it's a lot thicker than a standard table. If the Siegmund 28mm is too big or just out of your scale, you might want to look at its smaller brother. Coming in at 6,780 is the Siegmund 16mm table. The System 16 table has a 50mm grid pattern that goes around the 16mm hole. The thickness of the top measures about 12mm, or roughly about 1/2 inch thick. The sides also measure 12mm. The table has a 4-sided 100mm perimeter. It has this cool linear scale on 50mm increments. The tabletop is coated with nitride, so this is going to help with weld spatter. It is a little bit high if you're sitting at it, but it's not unbearable. And of course, I put my TIG pedal because there's no cross braces and easily still run a broom underneath. But without the cross braces on here, you do have to be careful when moving them because you could potentially bend the legs. The legs are constructed out of this really lightweight tubing, like 2.5 inches by 2.5 inches. Time for the rigidity test. I have 3 legs touching the ground and 1 is just barely floating, putting this table in maximum twist mode. This table is a limp noodle. I ran out of adjustment on the bottom foot and had to put a shim plate in to even try to get it to tripod. It just wants to keep twisting and twisting and twisting. So let's level it and see how flat we can get it. No matter what I do, I cannot get this table flat. There is a high spot in the center. So therefore, I'm left with about a 25 thousandths on the corners. These legs aren't doing anything. They're literally floating to try to get the center to come down. I don't know if it's just me, but the leg is not in the middle of the table and it kind of bugs me a little bit. So does this table pass in this configuration right now at this moment in time, the aerospace test? No, it does not. Let's use the big straight edge and the big precision machinist square and just confirm that the grid pattern is perfectly 90. Really nice. The grid is a grid. Amazing. 30 thousandths sag out at the end. So that's how much gap there is out here. So the sag is coming from this side not being perfectly 90. I can get easily a 5/1000 shim and this 100mm. Let's walk the square around the perimeter table and see what we average out. I was roughly able to get a 5 or a 7/1000 shim in between the square and the surface edge of the table, which kind of aids in this sag when you put a fixture down here. 389 kilos is 857 pounds. Let's talk about fixtures for the System 16. The squares are cast iron and they're machined for accuracy, and they all have this multiples of 16mm holes on a 25mm grid. Siegmund has a small abundance of steel stops and small squares. They got V pads with these really deep cross V in them. Ball lock bolt. The design incorporates 3 hardened steel balls with a really nice heavy knurl, and it measures 16 millimeter in diameter, right? But just for comparison, this is the 28 millimeter to put them side by side. Clamps, they got a few different styles and shapes. This clamp is just a straight pin with a slider on it to adjust where you want to hit your material, but this is just for pushing down. The next one is a swivel on 2 axes. And also you can pull off one side of it and just push with it. So you kind of get 2 clamps in one with these. This one is pretty good. This one is also just a direct down pusher. This clamp's pretty cool because of where they positioned the pin. It's right underneath the spindle. And that's going to prevent the clamp from wanting to twist when you're clamping. Let's test to see how powerful they are. The first one is vertical round with the bar style here. The minimum distance is about here. If you have it too close to the pin, it won't grip. 496 pounds. Now let's stretch it out, 268 pounds. Okay, let's test this style now. 750 pounds. Stretch it out, 365 pounds. Okay, one more. At its closest, 550 pounds. 507 pounds. All right. If I had this System 16 table, I would use it for smaller projects. Things like motorcycle frames, smaller items that needed this close 50 millimeter bolt spacing for the fixtures and the ball lock bolts, the really tight grid pattern on the table, and the 12 millimeter thick table top. The one thing I do like is how many holes they placed around the perimeter of the table. At 25 millimeter bolt spacing, that's pretty nice to have that many options. If metric isn't your thing and you'd like to use imperial measurements, well, the next table we're going to review is the Buildpro MAX 5/8. This table costs $5,145 and $6,090 for the nitride coated surface. So the table measures 8 feet long, 4 feet wide, and is currently sitting at a height of 31 inches, but that's variable because Buildpro has provided pins to adjust the table legs according to your needs, or you can choose a straight fixed leg or a leg with casters. And the build construction is made up of 16 individual surface plates that get bolted to the top of the frame and then drilled with a 5/8 hole on a 2-inch grid pattern. They're ground on both sides. You can flip the plate over and have a whole clean side to start over with. You can also offset the plates to the side by staggering the bolt holes and create almost a 7-foot wide table if you need that extra capacity. The way Buildpro fastens these plates to the frame is pretty unique. They weld the frame all out with this 2x4 rectangle tube construction and then attach this heavy 1x3/4 bar and weld that down to the top of the frame and then come back and machine the whole table after it's already been welded. And then they bolt the plates right on top of it. The holes in the table have these really beautiful chamfers so that the tooling just slips right in. The table weighs 1,283 pounds. The table ships in a large crate, fully assembled with the plates already bolted to the frame, but what you do have to do is add the legs, and they're really easy to install. They just thread in from the underside, and then you can attach these cross braces, and as you can see, you can adjust them anywhere you like, top or bottom. Let's talk about ergonomics. I'm sitting at the table, and I could definitely sit here and TIG weld if I wanted to, or stand and work. This cross brace is in my way, but I could remove it if I sat at this corner of the table often. So I just got done measuring the table, and the maximum sag I could get with this frame fully twisted is 50 thousandths of an inch at the center. But now it's time to see what's the maximum flatness I can get out of it once we get the table all flat and level. I was having a hard time getting the table really flat, and that 2 of the bolts on these plates in the center here weren't quite as tight as they needed to be. And when I sucked them down with the Allen wrench, everything kind of straightened out and I didn't have a high spot anymore. 4 thousandths gap was the largest I could get anywhere on this table with the straight edge. That was just in one place over one plate. The table passes the aerospace test, especially since the construction of the table allows you to put shims underneath plates, do what you need to do to get the plates all in alignment to get the table perfect. Something to be aware of, there is quite a bit of deflection out here on the end. Probably almost a 1/16 of an inch of sag. When it comes to fixtures, Buildpro has no shortage of a selection. They have mild steel cubes that have been machined on all 5 sides, and these are highly accurate. I've measured them myself. And then moving down to a cast iron 4-sided square with a plethora of holes in there for both sides. And since these are cast iron, these are going to be great for weld spatter. And then moving down to a fabricated mild steel, welded together and then machined afterwards. And then these are black oxide coated 90-degree fixtures that have been welded together and then machined too. And then just sliding bar style, low profile stops. And then an assortment of attachments from 90-degree or 120-degree V-pads. You have your adjustable stops. And then you have some height adjusters and then side pushers. And then something like this edge plate, which you could use it on the table all by itself or flip it over and grab the bottom of the table and give you that 5th side to extend your table off. This is the ball lock bolt with its toolless design to attach the fixtures to the table or fixture to fixture. And then if you have something weird and strange, then make an adjustable to where maybe you want a custom fixture for your table and you want to build it yourself, you can get these adjustable ball lock bolts. Multiple different styles of clamps. These are the inserta pliers for your low profile applications. And then you have your sliding bar clamps from 4 inches, 5 inches to a cam over style. And then these are your tilting clamps to get at weird angles. And then you can also take them out of their holder and use it to push on the side. And then you have adjustables to get close and far if you're not able to hit the correct hole. Quite a few different options. I think we should test them, see how strong they are. It's gonna go till I don't see it going any higher. 1,124 pounds. The little guy here, 771 pounds. So this ratchet just works just like this. Another 771 pounds. This is the inserta pliers, 352.74 pounds. Just the medium. I don't know if I'm gonna be able to reach it. 650 pounds. It's grip strength here. Whew. 361 pounds. The further out you get, it's gonna have less power. The closer you get, it's gonna have more. So let's check out this drop-in style at its furthest extension point. 529 pounds. Now let's test it at its shortest distance. 970 pounds. This is the round rod clamps at its furthest point. 297 pounds. Shortest distance. 582 pounds. Here's some things that I like about the table. It's rigid. I can adjust the surface plates. I can flip the plates over and have a nice clean work surface. The plates are staggerable. The cross braces on the legs are removable, or I can adjust them. I like that I can adjust the height according to what I'm doing, and the build construction is top notch. You can get a nitrate coating for anti-spatter resistance, and then the fixtures alone are worth a ton. I can buy individual plates in case one of these were to get damaged. There's not a lot of things that I don't like about the table. This table is not 5-sided. This table could be called a light duty table only because it has 5/8 holes and a 5/8 thick plate. But overall, I think this table is fantastic. I feel honored that Buildpro asked me to unveil their brand new 28mm max table, and here it is. This table will cost you $8,090 with the legs included. The table measures 1,200 millimeters wide by 2,400 millimeters long, or 94.5 inches to 47.25 inches wide. The tabletop's constructed of ground steel plates measuring 25 millimeters or 1 inch with 28 millimeter holes on a 100 millimeter bolt spacing. The table is nitrate coated to help with weld spatter. Because it's in metric, it's undersized of a 4x8 table. If you want to put a 4x8 sheet of steel on this table, you're gonna have material hanging off the edge. I like this. It measures about 34 inches tall with an 8-inch side or 200 millimeters. Easy to put my knees underneath, run my pedal or sweep a broom. What I love is that there's no cross braces. These legs are super stout. It looks like 4x4, and they put a giant base plate up here in the table, which will help with the rack and keeping these legs straight so you don't need any cross braces. Really nice leveling feet that are easily adjustable with a large wrench. The legs are set inside the frame, which I like. The frame's constructed of 2.5 by 5 inch rectangular tubing with a piece of flat bar welded on top that's machined, and that's what the plates are bolted to. And there is another pad in the center of the table to attach a center leg. Let's give the table a twist to test the frame's rigidity. With the table tripoding and the fourth leg floating in air, had the maximum gap here about 40 thousandths in the corner, which that's really good. Let's level this baby up and see what its maximum flatness is. I'm trying to find a place where I can get a 3,000 shim underneath this table, and it's just not happening. Except for the one little tiny 6x6 area where there's a plate transition, I was able to get a 5,000 shim underneath it, but that is the only place I was able to do that. What I want to know is the grid on the table a real true grid and how accurate the holes are placed. I don't see anything that throws a red flag at all. The holes are totally reliable. How accurate are the four sides to the top? Woo! Look at that. Pretty straight. Does this surface continue to be flat all the way out to the edge? We're gonna find out. This is a 3,000th shim and I'm not able to get it underneath anywhere. That surprises me. Okay, I'm pretty happy with the way this table measures out. What I like is we're able to unbolt the plate and offset it one bolt hole and do the same thing as this extension right here that I'm sitting on. So let's test that next. 5/6 thousandths deflection, 180 pounds out on the end. 0 deflection, unloaded. All the plates are machined all the way around. So this table is designed for a little bit heavier weldments because of its thicker plate and larger hole diameters. Table measures fantastic, except for that little tiny 6x6 area in the corner over there, but I think that can be manipulated. Overall, man, it is absolutely brilliant. This passes aerospace. I don't see anything wrong, and I know that I can make the accommodations to get it there if need be. 1,145 kilograms is 2,524 pounds. It's pretty heavy. Let's take a look at the 28mm clamps and fixtures that Buildpro offers. We got 80 centimeter tall, 3-sided fixture blocks. These are for going vertical on the welding table and being able to hold and fixture up to 80 centimeters tall. And it has 4 machined sides on it with all the holes that you want. It even includes this cool slot for doing some angle adjustments. And I like that they have big long slots in these smaller ones. Enabled to hold tubing and pipe, they have these cool V-blocks. And then you get down to even the smaller stops where they're just singular bars with a slot in it and multiple holes for precision locating. There's 2 styles of clamps and they both utilize just a screwdriver grip to tighten. You have the sliding tube and the sliding arm where you can drive the rod through the center of the table. But all the fixtures are machined, flat, square, precision, and they're all nitride coated for spatter resistance and rust. The smaller stops are fabricated and machined steel, and you start getting to the larger fixtures, they're made of cast iron. And then of course we have the really heavy duty ball lock bolts, and the one thing you'll notice on the table is everything is standardized. So one ball lock bolt will fit all the fixtures. You don't have to have 2 different sizes. Let's take a look to see how much clamping force that these clamps can generate. Okay, we'll do the closest settings and then we'll go all the way out and see what we got. That's 890 pounds at its closest, 679 pounds. These type of clamps are kind of unique in their construction. They're basically 2 components and it has this collar on the bottom so that when you insert it into the hole that you can hold its height and it doesn't fall down. And it's just held in by an O-ring. And this is the clamping down orientation. But then you can pull this part out and now you can put it into the hole and now you can clamp sideways. And this is on a hinge to account for angularity and a really cool V pad which has got a slot in it and a V that goes the other direction to be able to grip on your material. The one thing that is strange is that you cannot put a wrench or a socket on this anywhere, and the only way to tighten it is just to grab the handle. The next clamp we're going to test is this sliding dial, and you can remove this top. First of all, you can see the 2 components. You can flip it over. Now you can push vertically, and this does not rotate, and this arm slides. And there is a locking screw on the side, holds it from slipping down. And what's unique about this is if you pop this apart and unthread it, you can pull out this nut, which has the Acme threads and the pusher, and now you can insert it into any one of these holes. So now you can use the hole for repeatability in the table. But let's put it back in. Test the clamping force. We'll test it as close as possible. That's 705 pounds at its closest. It's 507 pounds at full extension. Here's my final thoughts on this brand new table. The table shipped in a large crate with the legs separate. You're gonna need some mechanical advantage to get the table high enough to put the legs on. And one thing I like about the table are the plates. So you could flip the plates over and have another clean working surface, or if it gets damaged, just replace it altogether. Currently, Buildpro only offers this in metric, and I wish they'd come out with an imperial system. I think that'd be really nice. Because this table is undersized from a standard 4x8 table, I'm not able to get clamps or fixtures around it just by using this working surface. I have to now add extensions to get around a 4x8 piece of plate. With that being said, that's still not a deal breaker. This table is very well engineered and put together, has a lot of thought put into it. This table is maintainable with its removable plates. It's really strong. It's very well constructed, it's flat. What I notice is the table has these really big chamfered holes and all the tooling just slips in really easily. Being this is a Buildpro table, they're gonna continue to build fixtures and continue to add to the product line. There's just something about this all black construction of this table that just really makes it look cool. Very stealthy. If you're after a heavy duty table and you like to work with metric and want an option to a Seigmund, this one might be your best bet. We're gonna take the table size down a little bit, and this is Buildpro's cool little Rhino Cart. The cart will set you back $2,090 without the fixtures, or $2,750 with the fixture package. The table measures 48 inches long by 30 inches wide, and it measures 36 inches tall and has a 5/8 thick mild steel top that's been nitride coated with holes that are 5/8 in diameter on a 2x2 grid pattern. The table weighs about 550 pounds. This cart comes in like a flat pack and you have to assemble it all. But what you do get is a cart, a 66-piece fixture package. On the side of the cart, you have some clamp hangers, and it comes with some shelving in the back over here, and it has a really cool plasma cutting or torch cutting table, and then it just folds out of the way when you're not using it. And then that gives you an extra 5'9". Comes with casters so you can roll it around. 2 of the wheels are locking if you want to permanently mount it in a location. And then it has leveling feet. The frame has been welded together in a grid pattern, and then they fasten the top to it with these cool clips. That way you can undo the clips, flip the table over, and then you got a whole brand new surface again. One thing I can see about the table is that if you like to sit and weld, this bottom tray kind of gets in your way of your feet, especially if you were to TIG weld, you'd have to move your pedal off to the side. But overall, that 36-inch height is a great TIG torch height. I'm gonna measure the tabletop just sitting on its wheels first to see how rigid the table is if you were to pull it right in the middle of the garage. It's tight in the center, and then the edges, it falls off. I was able to get a 10,000th shim underneath the corners, measuring diagonally, but let's put it on the jacks and level it up perfectly and see if that takes some of the flex out of the frame. The middle is still high, but it has like a dip between the center and the end. I'm not seeing any real change. I can't really get it much better than the 10,000ths of an inch. Right here in the center, pretty acceptable, and it's probably gonna do what most people need it to in this price point and size of table. But no, it won't pass the aerospace test. One of the best things I think the Rhino Cart does for you is give you a pretty good starting assortment of fixtures. They start you off with some angles, 90 degrees. I use these the most. And then some edge stops that have a really long slot to really position your work. And then you have magnetic risers. You can place these anywhere on the table. And you got some 120-degree V's and also some other magnets styles for round tube. You got a wrench to tighten all your ball lock bolts up. And then one of my favorites too are these side pushers. And this is kind of like using the table as a vise or a clamp. And then your ball lock bolts, these position your fixtures down to the table. And then of course all your hangers for the front of the table. And then 6 clamps, some inserta, and the sliding bar clamps to hold your work down. So my overall impressions of the table are pretty positive. This table is going to be fitting for somebody that doesn't have a very large workspace, with all the shelving, storage, giving you fixtures, a double-sided work table, a nice thick heavy top, and then this quick fold out table for plasma cutting. It really does pack a lot in a small package. And then you put some wheels on it to be able to position it anywhere in your building or facility you want. And this table really isn't designed for sitting at, so that might be a problem. I think I would just leave it on the wheels. I didn't really see a general improvement on putting the leveling feet underneath there for accuracy. But other than that, I think it's a fantastic little table. This cart is designed for somebody that has a small space but needs a lot of value. And I can totally see that with this little unit. If you're the type of person that likes a more hands-on approach, then you might take interest in the Certiflat FAB Block table. This table, as you see it here with the legs and casters, costs $3,500, or you can purchase just the top only for $2,900. For a 3/8 or 1/2 inch thick plate table, the price is going to go up. And this is a DIY build-it-your-own kit table, and it comes all laser cut and ready for you to weld together. The table measures 4 by 8 top with these 8-inch sides, and throughout the whole table is a 16mm hole on a 2-inch grid pattern, measuring 40 inches tall. The table is constructed of hot rolled pickled oil plate, measuring a 1/4 inch thick. And overall, it took me about 8 hours to put this whole table together. In my opinion, it's going to be a little bit tricky if you don't have the right tools. Certiflat suggests the more time you take in assembly, the flatter the outcome of the table will be. Certiflat has a really cool little system they got here, and it's ribs designed to interlock together to form a work table surface. Once you pull the ribs out of the box, you can now slip the ribs together and form a grid pattern. And after you get the whole grid pattern together, you install the top. Where the two plates intersect forms this cool connection which they call a tab and slot. The frame and the top become one once you get all these welds together, and it does this by having about 11 ribs through the 8-foot dimension and about 5 or 6 going the 4-foot dimension. And then I ordered the leg kit with the table, and the leg kit is, I think, my favorite part of the whole table actually. They have a laser cut tongue and groove system where the leg slots into the cross braces. The bottom of the table has a flange, and the top of the leg also has the mating flange, and that way you can just bolt the whole table to the base. The leg kit just includes wheels, no leveling feet. So I'm standing at the table, and it feels a little bit high, but it's not too uncomfortable. But when I sit down, it's pretty tall. And this cross member and the leg, they do work, but I'm not able to really run my TIG pedal. Kind of uncomfortable to sit at. I was really hoping that the design of the table with all these ribs and grid in here would just make it really easy to assemble, which it was, but I did have to monitor to make sure that I didn't weld it in a warped condition. It is not foolproof. You need to watch it as you weld the table out. After I was done welding it, I took a bristle brush, just kind of removing all the loose grit. Now the time comes to see if the table is Certiflat or if I welded it sort of flat. The first test is I want to test the rigidity of the tabletop alone. And in order to do that, I have separated it from the base, physically unbolted it, and now I'm able to put some twist in it by jacking the tabletop up. I have a control over its twist, and then we can measure it. So I'm able to get a 75 thousandths shim, not quite 100, so it's probably around 90 thousandths low in the center with twist. There's quite a bit of flex in this table. So this is what the table could be doing as it's rolling around on the floor. Now that we've seen how much flex the table actually has, let's get it as flat as possible. So the table sitting on the floor on the base still has twist in it, so I need to shim up the legs. So we have 25 thousandths low down in the corners, and then we're high in the center. Is it as flat as they claim to be, 30 thousandths in 8 feet? Yes. But does it pass the aerospace test? No, it does not pass the aerospace test. Because of this 1/4 inch plate, I believe, it's just a lot of lumps and bumps throughout the whole table. It's gonna follow the floor. This is the best as the table's gonna get. I want to measure the holes next and see how accurate the grid pattern is. The laser, being that it's a CNC machine, did a pretty good job. I could see maybe 3/1000ths of an inch variance as it goes up through the holes, but that's fantastic for a welding table. I'm going to leave the jack in place for the rest of the table as I measure it, because it's making the table flat. The sides are fairly square. There's probably 3 to 4 thousandths twist as the plate goes along, but this top surface plate is beyond the face of this, which is causing the square to have a 10 thousandths gap between the top plate and the side. Here's what I'm guessing the problem is this plate steel is measuring under a 1/4 inch thick. That's giving us that 8 to 5 thousandths variance. But let's measure down the sides and see how flat the sides are. And there's about 3 to 7 thousandths of waviness, but it doesn't exceed 10 thousandths of an inch in any direction. Okay, it looks like we got 461 kilograms. That's 1,016 pounds. Of course, Certiflat has fixtures to go with their table, and they're all this flat pack 1/4 inch plate steel design, and they have this tab and slot construction where you put the two plates together and tack weld them wherever those two connections meet. And then they all have holes in them for the 16mm to be able to bolt them down to the table if you so choose. And they come in a variety of different sizes. And of course, they're on a 2-inch grid pattern. Another neat thing about Certiflat is if you have a special fixture that you want designed for an application for your assembly, they will design it in-house and then laser cut it for you and deliver it. Let's check out the clamps. These are Bessie clamps with the 16mm peg, and they're on this sliding bar design, much like the others, and they have a nice big swivel pad. They only come in this one size. And of course you can get pins and stops along with a locking bolt to fasten the fixtures down to the table. And it has a 2-ball construction instead of the normal 3, and they put this O-ring on here, and I'll explain what that's going to do here in a second. But in order for this to work, you dial this body to get the correct height of fixtures you're working with, and then you insert the two together. The O-ring in there is providing friction so that it stays there, and then once you get it set, you have to use a T-handle, and then it locks together. The table has no chamfers in it on the holes, so it's kind of already starting to wreck the O-ring. Be aware that this ball lock bolt is a little more awkward than the other ball lock bolts that I've tested. Let's bolt the fixture to the side of the table and then measure its flatness across the whole surface. Measuring 16 thousandths gap out here at the end and 12 inches. Clamping time, pretty straightforward clamp made by Bessie. Shortest distance, let's see how much power it has. I gotta be careful that I'm not gonna bend the plate here. I think I'm gonna stop because I'm bending the table a little bit. 1,003 pounds. Looks like at 137.47, I'm just bending the table and the rod. 330 pounds. And that's the other problem. I actually raised the back of the corner of the plate. I can feel it with my hand. I'm gonna fix the table. I'm just gonna file it back again. See how tight that is? And then this one where I just clamped. I damaged the hole. Be careful with your clamps on these 1/4-inch tabletops. So here's my final thoughts on the Certiflat table. I'd be a little concerned about the 1/4-inch tabletop. I feel it's a little bit too thin. I would look towards maybe the 3/8 or the 1/2 inch that they sell. I'm just seeing that it's gonna be hard to maintain its flatness over the years to come. And just having that clamp in there, I didn't feel like I put too much excessive force on there, and then I oblonged the hole, and now my hole is permanently ovaled. And then it didn't quite measure as accurately as some of the others that I've measured before. The positives are that it's a little bit cheaper than some of the other tables. I feel like the 8 hours spent to get this table as flat as I could, it's still not as flat as something that I could buy and machined and known that it's flat. This is the problem of a DIY table, is you don't know what you're gonna get when you're done. My skill level might be different than yours. My tools I have in this shop are different from yours too. So I'm gonna put it back on you guys, how much time you want to spend on building your table and how accurate you want it. If DIY tables still interest you, well, Certiflat has a much smaller version called the Pro Table. This table's $400, standard with legs, or $250 without. This is their 4-foot by 2-foot model with the 3/16 of an inch steel tabletop with 16mm holes on a 2-inch grid pattern. The whole table assembly weighs 118 pounds. And this is a do-it-yourself kit. Comes in a flat pack assembly, and you pull it out of the box and you link all the components together and weld the table as a unit. And they have these cool tab and slot surfaces where you can weld all the joints together to try to keep distortion out of it. I've purchased the table legs to go with the top. They're sold separately. The legs are pretty cool construction. They have laser cut, so they just link together too and latch and hook to the table. And then you put wheels on it to roll it around. Standing at just under 41 inches. Pulling the table out of the box, I noticed how nice the laser cut parts were, and the assembly went really easy and fast together. I assembled this table with no flat reference surface, something that you guys would do on the floor or on the ground. It was hard for me to know where flat was because I was actually able to put some twist in the frame just with my 2 hands. What I did notice is the table didn't have the rigidity to make itself perfectly flat just with the assembly that I was given. We'll measure the table for flatness momentarily, but we'll continue to look at some of the ergonomics. It's a little bit tall to sit at. the leg brace design being so low, it's right in my way to TIG weld. It's a little bit awkward for myself, but being that it's on wheels, you could definitely move it out of the way to sweep under. No leveling feet were included. The table is very lightweight. I can move this around or even almost put it in the back of a pickup truck myself, but let's measure it to see how flat it is. So what I did notice is the table has a lot of waviness to it. I was able to get about 35 thousandths of an inch under some of the edges around the table with the straight edge. It's high in the center. With this table's build construction and its price point, this is kind of what I would expect to see. But is this a high precision table? No. Would I use this for aerospace work? Probably not. But this is something that you can assemble in your garage and have a work platform to be able to clamp your work pieces too. So let's talk about some clamps now too. Hole clearance in this table, pretty sloppy because of the thin tabletop. This table is designed for some light duty work. So therefore you're not going to be really looking to put a ton of clamping force by using this table. The clamps are stronger than the tabletop. So let's stretch this out. That's 220 pounds. Now what I want you to be aware of, that was extremely easy to turn and I could keep going. But watch what happened to the table. I've pushed and bent the whole of the table with very, very little pressure. I'm gonna have to take a file to the edge of that hole now because I've mushroomed it out and even dented it. You can exert more force than the tabletop can handle. I wouldn't go anything past 100 pounds of force with a tabletop like this. So I have the clamp set at 100 pounds, which was just one turn of the crank, and I'm already lifting the table surface up. You can see the straight edge, how it rocks right at this place. So every time you use the clamp, you're just lifting and raising and flexing this table. And so over time, I don't know how it would hold up. That's 100 pounds of force. I'm still able to pull that out from underneath there. I won't leave you guys hanging, so let me show you a clamp that's more designed for a table of this size. They're tiny little guys with only a 2 3/4 inch arm length and a little bit different method of fastening it to the table with this, I call toe and heel type construction. And that way, when it goes inside the hole, it spreads the load out on the back side of the plate and the front side of the plate, and this prevents the hole from getting distorted. And this is something that Buildpro doesn't sell, but I will leave a link in the description below so you guys can find these clamps. Something to note with this clamp is that they're designed for a 3/16 tabletop, not the 1/4 inch. But I don't see why you couldn't shave off a 1/16 of an inch on this little toe right here with the grinder and use it on your 1/4 inch tabletops. And also for the plier, it slips in much like that. The downside to them is you have to open them up almost all the way to get them to go in the hole, but it really spreads the load out where it's supposed to be to prevent damage. So what I'd like to do is do a clamp test on them and we can compare to see if we can see an improvement between this design and the one that just goes in the hole as a peg. All right, let's check out. Let's see if we can see a difference. 705 pounds with this little tiny clamp, and there's almost zero plate distortion. Just the tiniest bit. Much better design for a thin tabletop. Who I think this table would be great for is somebody that's in the mobile work. Somebody who wants to take this, throw it in the back of their pickup truck because of its lightweight construction and design, and move it to a job site and have some welding capabilities on location. Really use its lightweight to its strength. And also for somebody who just deals in really lightweight work that doesn't need a high precision table. Something else positive is its price point is really reasonable and something that an entry-level welder could get into. That way they can test the waters and see if welding is right for them. Here's something a little different. Here we have the Fireball table topper, and this table is designed to sit on a work table or a cart like we have here or a toolbox, and the table costs $950. And the overall size of this kit is 3 foot by 2 foot, measuring at an impressive 1.25 inch thick solid cast iron with 5/8 holes on a 2 by 2 grid pattern, and a beautiful black oxide finish over the top. Sitting on a frame that's made out of 1 by 2 solid aluminum bars and a ladder frame construction, giving these individual plates the rigidity they need and accuracy. These are 1 by 2 plates that are held together by these Allen fasteners that bolt right into the frame underneath of it. And inside of the plate goes this sleeve, and the sleeve sits in this pocket right here in the plate, and then the bolt goes inside there. And on the bottom of the sleeve is this locator pin that grabs the bottom of the frame Each of the plates could be used individually or added to this frame like we have it here. And you can see a real big, huge boss. And the boss is designed to be able to sit on top of a flat surface all by itself. And a ball lock bolt that will grab this machine part has room and clearance to stick through the bottom and not interfere with your table. And all the bottom and the top have these beautiful chamfered on each of the holes. That way the ball lock bolts will grip onto it and not damage the hole. The actual flat plate measures 3/4 of an inch. Assembly is real easy. All the sleeves just drop in. And this keeps the bolt spacing from hole to hole across the two plates perfect. Once you got all the plates down on the table and you want to take any sag out of the frame, we included this little leveling foot here. So now let's measure how flat it is. The maximum gap that I could really measure was in some slight places I was able to get this 3000 shim underneath there, which for a machine surface, that's pretty good. So yes, this table passes the aerospace test, which is 5 thousandths over 2 feet. This is able to do 3 thousandths in 3 feet. This little cast iron table weighs 187 pounds. Another neat, great feature is being able to use all the Buildpro tooling. So let's do a clamp test on the cast iron to see how it holds up. And you can see you don't get a lot of movement on the clamps. Let's see how the cast iron handles maximum force. Because when I designed this table, I wanted the table to be stronger than any clamp you can put in here. At what point does the meter stop going up? That's the maximum pressure we can get, so something's bending. 1,455 pounds. Let's check the table, see how it handled that stress. Put a scratch in it. So that was a extreme test and it raised just a little tiny, but that was with a cheater bar. I can kind of feel the ruler rocking, but that's super extreme. So I love knowing that the table is stronger than the clamp. So some overall thoughts on my opinion on my own table, which is kind of negate, but building something that'll last for a long time. That's why cast iron is great. Some cons about a table like this is that it doesn't have any legs and the price is a little bit more because you're paying for a premium material that's been machined. But overall, if you're looking for a table of this size and quality, whether you're a beginner or a professional, I think this table will suit your needs. So you've seen all these fixture tables and you're asking yourself, why not just use a big piece of plate steel? Well, we're gonna find out why. This is gonna be a little bit of a bonus clip. I wanna clean this 2.5 inch thick 5x8 solid steel welding table off. And then I wanna measure it since I've never seen how flat it is. So hopefully you guys will enjoy learning something about this big plate steel today with me. And this plate steel has a little bit of history. I heat, beat, hammer, do all the hard stuff on this table. So let's see how flat it is. It's not sitting on a leveled base or anything. It's just sitting on a 4x4 1/4 inch wall square tubing frame that probably weighs about 400 pounds by itself. And it's just gravity just sitting down on top of it. You cannot pick up one corner of this plate and make twist. So we're gonna measure it just how it sits. So I'm really curious to see if something like this is an option for you guys. I checked with my local steel representative. This is about $4,400 to buy a piece of plate steel like this. This is 2020, but let's just measure, see how flat it is. So even at 2.5 inches thick, you'd think a table this thick, it would be super flat. So that's 100 thousandth shim and it goes under like it's a bridge. So we got quite a gap underneath there. There's 1/8 of an inch. So 1/8 of an inch won't go underneath. Turn the straight edge around and go the other way. So I've measured it this direction, the diagonal, and it's 105 thousandths low in the middle. This is shaped like a bowl. That's great information for my knowledge. The base is inboard quite a ways. So I know that the table isn't sagging because of improper support. It's just mild steel plate that's been rolled. So this is something you'd be expecting. And the thinner the plate thickness gets, the worse this is going to be. So that's a good little piece of information, knowing that if you were to get a big piece of plate steel, regardless of the thickness, is don't count on it to be really flat. So that's just a little bit of information that I thought I'd pass on to you guys. Hopefully this video helps you guys on your quest for your perfect welding table that suits your needs. So thank you guys for watching, and I'll catch you on the next one. Could look like a potato chip. A potato chip, a potato chip, potato chip. Does it look like a potato chip?